All right, welcome to activity 3.5, applied statistics. Okay, before starting this assignment, make sure you have looked over the PowerPoint and also please read this section, okay? Do a few definitions here. And then once you've done that, let's go ahead and look at question 2. Feel free to pause this and stop this anytime you feel necessary, okay? So question 2 here, or procedure step 2. Part of the manufacturing quality control testing for a toy is to measure the depth of a connector piece that must fit into another part. The ideal depth is 4.1 centimeters, but parts close to 4.1 centimeters are acceptable. Every 10th part produced on the production line is measured. The following data was collected during a 2-minute production period. So these are all lengths of a part, okay? So you have this data, okay? For part 2A here, we need to calculate each of the following measures of central tendency. Show your work. Okay, so you're going to be doing this in your engineering notebook, but first we have to calculate the mean, the median, and the mode. Okay, I'm going to show you how to do that right now. Okay, so I made a data set with values that are very similar to yours. They are slightly different, so I will get different answers, okay, because I don't want to give away the answers. I want you to calculate them. All right, but basically these numbers are very similar to what you have, okay? So the first thing you need to do is arrange them from the lowest value, the minimum value, to the highest value, your maximum, okay? So arrange all 12 values and put them in order from lowest to highest or minimum to maximum, okay? All right, so once you've arranged them from the minimum to the maximum values, all right, we can go ahead and find the mean, okay? So the mean's pretty easy, okay? You basically just add them all up, you find the sum of them, and then you divide them however values you have here. And we have 12 values total. So you add them all up then, and you just divide them by 12, okay? If there were 10 values here, you would add them all up and then divide by 10. But as in this case, okay, we have 12 values. Okay, so go ahead and do that. Add them up, divide them by 12, and that will give you the mean, okay? I got 3.96 for mine, all right? Yours will be slightly different. Your answer should be different because, well, your values are different, okay? If you watch the PowerPoint, well, you might have read somewhere that says when you find the mean, it's important to round to one more decimal than the original data. Okay, so notice, all of these are in the 10th spot, okay? So when we do the mean, all right, we add one more decimal place here, so the hundredths. Okay, so the next thing we need to calculate for part 2A here is the median, all right? So the median are our center values, okay? So if you had an odd number, all right, you'd have only one center number, all right? But since we have an even number, we have 12, okay? In this case, because we have 12, we have two values we have to take into account. We have 3.9 and we have 4.0, okay? So to find the median, we'd simply take our two center values here, 3.9 plus 4.0, and divide them by 2. And that will give me a median value of 3.95. Okay? Now remember, once again, my values here are slightly different than yours. This way, you don't get the same answers, okay, as I get. Okay, now to find the mode, all right? The mode is the value that occurs the most in our data set, okay? So in this case, I only have one 3.7, so that's definitely not it. Well, I have three 3.9s and I have three 4.0s. So in this case, it's 3.9 and 4.0 that occur the most. All right, so my mode would be 3.9 and 4.0. It is what we call bimodal because 3.9 and 4.0 occur the same amount of times in our data set. Now, if I had one more 3.9 in here, all right, it would just be 3.9, okay? But in this case, it's bimodal, okay? 3.9 and 4.0 occur both three times in our data set. Okay, moving on to part 2B here. Now we need to find the range of our values, okay? So the range, how do we do that? So the range is calculated by taking our maximum value, 4.3, or our highest value, and subtracting it from our minimum value, our lowest value. Okay, so 4.3 minus 3.7 will give us a total range of 0.6. Okay, so once again, I don't know if because my values are different, I may or may have a different answer than yours. Okay, so that's part 2b. Now we need to calculate something called the standard deviation of our data set, all right, or our data values. So the standard deviation is very important in statistics. It essentially tells us the variation in our data, okay? If all of our values were the same, standard deviation would be 0. That basically tells us that there is no variation in our data values, all right? So let's take this column, one column at a time here. So for this column, okay, go ahead and create a table like this in your engineering notebook paper, all right? So first thing we're going to do for this column is just list all of our values, okay? So you should have 12 total values here in our X column, all right? And once again, I would just do them in order from lowest to highest, okay, or minimum to maximum. So you can see all of my X values right here. I went ahead and put them in a table, okay, all 12 of them. So for our second column now, you're going to take our data values here and subtract them from mu, or which is the Greek letter for the mean, which we already calculated. So my data table, okay, 3.7 minus the mean, 3.96, and I got negative 0.26, okay? So once again, do that for every value, for all 12 values all the way down, okay? Go ahead and pause that. Pause this while you work on it, and then hit play when you're ready. All right, now for our last column here, you're going to take the values in this column and you're just going to square them, okay? It's that simple. So let me show you what I got. So I took my first column, 3.7. I subtracted it from my mean, 3.96. Okay, and that gave me a negative 0.26. Okay, now I'm going to square that value. I would put them in parentheses, close parentheses, then hit the square button. Okay, and there you go, 0.0676. Okay, and then once again do that for every value. All right, and then add them up. Now be careful here because that's a lot of adding. There's a lot of potential for error. So I would double check your work. I would do it twice just to make sure you get the right number here. Now once you add them up, that's not our standard deviation. We're not done yet. Okay, so what we need to do is take this number here, divide it by 12, okay, because that's our data set values, okay? So I took this number, divided it by 12, which gives me 0.0273, and then I take the square root of that. And then that is our last step, okay? And that'll give me a standard deviation, all right, of 0.165, all right? Now remember, once again, my values are different, so my numbers or answers may or may not be different than yours or the same, all right? Now I know what you're thinking, you're like, wow, that's a lot of work just to calculate one little number, okay? Well, in our next assignment, we will be using Excel to do the standard deviation, okay? So it'll be much easier, all right? So remember, this number here essentially tells us standard deviation, how spread out our X values are, okay? Or the variation between them. If these were all the same number, standard deviation would be 0, okay? If standard deviation, the higher the number, the more spread out our values are, okay? Now let's look at, okay, part C here. Create a histogram for the data using the grid below that shows the distribution of your data. The horizontal axis should display each length measurement from the minimum to maximum recorded lengths. Use an interval of either 0.1, 0.2, or 0.3. You may choose to begin with a dot plot and then fill in the bars, and be sure to label your axes. All right, so notice I have my x-axis here with length centimeters for my part, and then over here is my number of parts, frequency, okay? So 1, 2, and 3, all right? So notice I gave me an interval of 0.1, 3.7, 3.8, 3.9, 4.0, and so forth. Okay, so that's the interval. That is the change between each one. Okay, so what I did then is just to put my data down here to help you out. 3.7. Okay, I have one block. 3.8. I have two of them. 1, 2. Okay, I did a dot plot first, which you guys can do as well. Okay, 3.9. I have 1, 2, 3. 3.9. 1, 2, 3. Okay, and then I simply turn them in the dot plots into bars. Now, don't just simply copy my graph down because I believe my graph is different from the data. Okay? All right, so question D and E here. Okay, you guys can probably figure out. So let's look at F here. All right, F's getting a little tricky. Add and subtract one standard deviation from the mean. Round your values to the nearest tens place. List these two values below. Okay, so basically, take your mean, okay? You're going to add your standard deviation to it. So when I did it, I took my mean and I added my standard deviation to it. I rounded it to the tens place, and here's what I got. Now, same thing over here, okay? I subtracted it now from my mean, and then I rounded this to the tens place. So I got 3.8 and 4.1. Now, it says here, using the two values from the previous question, now assume the company cannot utilize parts with lengths that are not within one standard deviation from the mean. Okay, which parts do not meet the required criteria? Okay, so 4.1 for me and 3.8. Now I got to look in. Here's my graph here. This is within one standard deviation, right? 4.1 here, okay, and 3.8. All of these parts meet the criteria. They're good, okay? Out here, not so much. Okay, so 3.7, 4.2, and 4.3 for me. Now remember, you're going to get something different, okay? So all of these parts are acceptable. They're within one standard deviation of variation, okay? Now out here, not, okay, not really. We have 4.2, 4.3, and 3.7. These parts would be essentially our rejects, okay? They are not, in terms of quality, they do not meet the quality we need for our company, okay? So, for the last part, for the last part I here, okay, you would simply add one more standard deviation here. For 2 standard deviation, you would add one more standard deviation over here, and you would subtract one more standard deviation, okay? That would give you 2 standard deviation, which is it's gonna widen our variation here, okay? You may or may not have parts or lengths that fall within this 2 standard deviation, okay? All right. Let me know if you have any questions in class, and I'll be more than glad to help you. Thanks. We'll see you next time.